Question 6, a random sample of 250 cars was taken. The mean was 4.5 and the standard deviation 2.2. Construct a 95% confidence interval for the mean age of all cars. So we're going from the sample back to the population, and we can say that 1.96 times standard deviation 2.2 divided by the square root of the sample, which is 250, will give me a value, two standard deviations, or exactly 95%, 1.96 standard deviations away from the average. In the middle here, we're getting a value at this point and at this point, and we're saying this confidence interval here, we could say the width of it even in percentage terms is 95%. So you've probably practiced a few of these before getting to this video. No harm to keep sketching these, get good at drawing them. And these questions really, they're very easy when you've practiced them. I'll give away marks at Leaving Cert Maths. So what is 1.96 by 2.2 over root 250? It's going to be 0.2727. Nice number, 2727. So we go 273. You take two decimals, probably fine too. So the mean of the sample was 4.5. So 4.5 plus 0.273 and 4.5 minus 0.273 is going to give us 4.773. 4.773. And that's a 3 there. Just didn't take the top of it. 3. 4.227 to get back up to the 0.5. So my confidence interval, 95% confidence, the mean of the population lies between the values 4.227 and 4.773. And in part 2, I think n is the unknown. What's sample size? So we're looking for n. So we need a formula with n in it as the only unknown to estimate the mean age with 95% confidence to plus or minus 0.3. Okay, let's look at our values here, plus or minus 0.3. So what would have to give us 0.3? 1.96 by standard deviation of 2.2 divided by the square root of n is equal to 0.3. I'd have to add it on and take it away. So if I multiply across by root n and divide across by 0.3, 1.96 by 2.2. Now divided by 0.3 is going to be equal to root n. So if I divide by 0.3 and let it equal, instead of root n, I've squared both sides. So I need to square this whole thing over here. That's going to give me a value for n. Now if you don't want to do it in one step, just calculate maybe this part first, divide this by it, and so on, and invert it if you want to do it that way. But one step at this point of sixth year is probably where most of you are at. It's 206.49, so we'll round n up to a sample size of 207. Question 7. Christmas tree lights are ready to be, or Christmas trees are ready to be cut and sold. 50 of the trees are selected randomly and the heights are measured in centimeters. And you're thinking, when you see this, please don't ask me to do a stem and leaf hell. Easy question, but I find it just really annoying. So calculate the mean of the sample. So we're just gonna, again, we're gonna have to add all these up. If they ask this at Leaving Cert higher level, the people who write the exams should be hung, drawn and quartered. So on a calculator, this is going to give you 147.22. It's just time consuming and you have to check your answer twice always on a calculator, so that's going to take some time. Don't rush it in an exam. And then construct a 95% confidence interval for the mean height of all 6,000 trees. The standard deviation is 23. So my standard deviation is 23. And a confidence interval for all 6,000 trees. So we're going from our sample of 50 back to our 6,000. So we have n is equal to 50, 1.96. Your calculator would allow you to get the standard deviation of this sample here, but we can use the standard deviation of the population by 23 over root 50. It's going to give me my value that I can add on to my 147.22, the mean of the sample. I have to add on and take away the standard error of the mean times 1.96, so that's going to give 6.375, 6.38, I'll just round it to 6.38, and if we add 147.22 to that and take it away, it's going to be 153.60, and if we take it away from 22, we're going 140.84. 140.84. So we can say that whatever this is, the size, is it random heights, the heights of these trees for the population, we can say with 95% confidence it's between 140.84 and 153.60. Last part, if the trees sell for 350 per 30 centimeters, give a lower and upper bound on the value of the 6,000 trees. Okay, so how many 30 centimeters have we got in 140.84? Well, if I divide by 30, you can see it's just going to be less than 5, 4 point something. And if I multiply that by 350, I'll get the value of the lower end. And if I do the same, I've got slightly more than 5 30 centimeters in 153.60 divided by 30 times 350. That'll give me the value that I need to multiply then. That's for one tree, so I need to multiply that by 6,000 and this one by 6,000, and I'll get the upper end and lower end. First one is 98,588 exactly. Loads of zeros before a 1 appears, and the second one 107,520 for the upper end. So we could write that's like a range of values, so we'll write it in square brackets 98,588 and 107,520 for the upper end of the range of the value of these trees.